Go.
Hey, I'm Alex Berry. I'm here doing a grade replacement for test number 1, because we have to. So my first problem, we have to find the area of a triangle bounded by the lines y equals 0, or the x-axis, and the tangent and normal line of 6x minus x squared at the point 5, 5. So this problem is kind of complicated, so we're going to take it step by step. First thing we need to do, we need to go and find the tangent line to this graph at this point. So to find a tangent line, we have to go and take a derivative. So our function is f of x equals 6x minus x squared. So our derivative of that is just going to be 6 minus 2x. Awesome. So now is tangent at this point, so 5, 5. So for our derivative, we're going to plug in 5, which is going to give us 6 minus 10, which is going to give us negative 4. So our slope at the point 5, 5 is going to be negative 4, so let's write our tangent line. Let's go look like y minus 5 equals negative 4. Remember, this is the slope of our tangent line. X minus 5. Awesome. So we've got our tangent line. So now we need to find the normal line. A normal line, it's going to look exactly like this tangent line, except we're going to, instead of having negative 4, we're going to have its negative reciprocal. So instead of negative 4 there, you're going to have 1/4. And that just means, like, on a graph, instead you go from having something like that to having something like that. And it forms a right angle. A normal line is always going to be perpendicular to your first line. So awesome, we have this, and so now we need to go back to our original question, which we have to find the area of a triangle. So we're actually just going to use simple geometry. Well, it's not exactly simple, but it's the best thing we can do. So let's actually go draw a graph. Come back over here, we're going to make these problems look a little better. So when we plug numbers in, it's going to be a little easier. So this is equal to y equals negative 4x. That would be plus 20, so plus 25. And then this right here would be equivalent to y equals 1/4 x. That would be minus 5/4 plus 5. So minus 5/4 plus 5. That's like adding by 25/4. So plus 20/4.
Oh, what? Yeah, that's right. No, 15/4.
Okay, sorry, 15/4. Thank you. 15/4, awesome. So we have this in slope-intercept form, so hopefully this will be really easy to graph. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is really stupid. 10. Okay. So now looking at...
You need 15 more.
Huh?
You need 15 more. Unless you want to make each line like 2.
No. I got this.
He's got this.
Okay. So, remember, we're bounded by... Our graph is bounded by these two functions and the y equals 0 function. Alright, here we go. So now we have our two lines. We have our tangent line, we have our normal line, and we have the line y equals 0 over x-axis. So now we need to go and make a triangle, right? So if we went and we graph this line, wherein x is 0, y would be 25, so remember each of these lines is worth 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. It's right here. When when your x is 1, your y is going to be 21. So when x is 1, your y is going to be 21. So 2, 4, 6, 8.
I just look for x-intercept.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 is right here, so 21 is going to be about here-ish.
Just use your slope.
Okay, and again, our slope is -4 over 1. So we can actually just, instead of solving for each point, if we just go down 4 and go over 1, we can find all our points on this line, or all our major points. So here, we go down 2, 2 over 1. Go down 2, 2 over 1. 2, 2 over 1. 2, 2 over 1. And 2, 2 over 1. Like that. And if we come back over here, our x-intercept, if we plug in y as 0, so 0 equals -4x plus 25. For x is going to be equal to 25. X equals 25 over 4, which is basically 4 1/4.
4 1/4, like 6 1/4.
Yeah, sorry, 6 1/4, which should be, oh, each of these is 2. 2.
He done goofed.
Stop pause the video.
Just correct yourself.
Okay.
Correct the line. Just say, oh, well, I fucked up.
Yeah, I messed up here because remember each of these points is in terms of 2 units.
Well, actually, okay, never mind. I say like you can have the y-axis to be 2 and the x-axis to be 1.
My friend has just reminded me of something. We're gonna make all the y lines equal to 2, so each y line equals 2 points, and each x line is gonna be equal to 1 point. And I know this is gonna look kind of funny, but it works because your y and your x-axis just has to be contingent in terms of a ratio. So all the x lines are equal to 1 unit, all the y lines are equal to 2 units. So now I don't have to redraw my graph. And so if we remember, x equals 25 over 4 when y is 0. So y is 0, x is 25 over 4, so 1, 2, 3, 4, 5, 6, and a fourth. That'll be about right there, which makes this line come down like this. Awesome. And let's remember this x equals 25 over 4, because we're going to be using this to actually solve our triangle in a second. So now we come to the normal line. Remember, a normal line is going to be perpendicular to our tangent line. So let's start off by finding some intercepts. When x equals 0, y equals 15 over 4, which is very close to 4, so when x equals 0, but we actually won't need that point because that would be somewhere over here, and that would actually be inside our triangle. You can tell because this vertex is higher than this vertex, so we don't even need that point. When the y's are 0, so now we're looking for that x coordinate over there. So when the y's are 0, 1/4 x plus 15 over 4 like this. Remember, all I did was plug in 0 for y. So negative x over 4 equals 15 over 4, which makes, multiply both sides by 4, negative x equals 15. X equals negative 15. I don't know why this didn't work as well when I saw this earlier. So x equals negative 15. Remember, our y's are worth 1. So we need to go out 15 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This should be about right there. So we go, we draw that line. Bam, awesome. We are so close to solving this problem. So now remember, we're looking for the area of a triangle. Area of a triangle equals 1/2 base times height, right? So now all we need to do to finish solving this problem is find the base and the height of this. This should be really easy. So our area equals 1/2. Let's look at our height first. Our height is just going to be from here to here. So that distance, and we already know the point of our top vertex is going to be, we just solved for it.
25. You didn't solve it, you said it was 25. Actually, no, you erased it, I think.
It's going to be 25, I think. Because remember, this is when our x-axis is in our normal line, or sorry, our tangent line, when your x's are 0, so like that. When your x's are 0, your y is going to equal 25, which makes this whole height 25. So now we have b times 25. And then we need to find the base. So our base is going to be this distance plus this distance, and remember that's all positive. So this gets really easy. Now we can just look at where our intercepts are on the x-axis. So we come back over here, and we know that one of our intercepts was -15, and another one of our intercepts was 25/4. So we just literally add them together, or add the absolute values of them together. So -15, we're going to treat that as a distance of 15 units, and 25/4, we're going to treat that as a distance of 25/4 units, which gives us 60 plus 25 all over 4, which equals 85/4 units. So now we plug that in as our base. 85/4 units. So our entire area is going to equal 25 times 85. Give me a second to do that calculation in my head. One second, do the calculation in my head. How the hell do you turn on the calculator? Pull out our handy dandy tool. So that gives you, thank you very much, Alan, for waiting for me.
Do you put it in your head?
Gives you that number, and if we divide by 8, again using our head, our final area is going to equal 265 625. And we label it as units. And that's problem 1.